Subscribe to Dr. Khalkar's classroom channel and press the bell icon to get latest updates. Hello everyone, I hope you are doing great. In this lecture video, I am going to discuss about unit number 2, that is laser and optic fiber. So let's get started. Laser is one of the most brilliant, colorful and powerful invention in the world. It serves as unique tool in the fields such as industrial, scientific, medical, defense and so on. You must be familiar with this, the laser pointer, which is one of the significant tool. It is everywhere in your daily life. In this lecture video, I have explained the topic laser, in which following points have been covered. Number 1, that is basics of laser and its mechanism. Number 2, characteristics of laser. And number 3, levels of laser. A laser is a device that emits light through a process of optical amplification based on the stimulated emission of electromagnetic radiation. The term laser originated as an acronym for light amplification by stimulated emission of radiation. Lasers are distinguished from other light sources by their coherence. Spatial coherence is typically expressed through the output being a narrow beam, which is diffraction limited. Laser beams can be focused to very tiny spots, achieving a very high irradiance, or they can have very low divergence in order to concentrate their power at a great distance. In this picture, you can see different sources of the laser with different colors. And in this neighboring picture, you can see the lasers used in laser shows. Now let's understand what is energy levels, excited state and ground state. A quantum mechanical system or particle that is bound or that is confined only take on certain discrete values of energy, that is called as energy levels. Whereas an excited state of a system, such as an atom, molecule or nucleus, is an quantum state of the system that has a higher energy than the ground state, that is more energy than the absolute minimum value. It is called as an excited state. Whereas the ground state of a quantum mechanical system is its lowest energy state. The energy of the ground state is known as the 0-point energy of the system. So these three important parameters are there to define the energy state of any particular system like atoms or molecules. Let's try to understand the basic important parameters which are important in lasing action, that is in laser. First is absorption of radiation or light. The process of absorbing energy from photons is called absorption of radiation. It is well known that there are different energy levels in an atom. The electrons that are very close to the nucleus have lowest energy level. These electrons are also known as ground state electrons. Now let us consider that the energy level of ground state electrons or lower energy state electrons is E1, and the next higher energy level or higher energy state is E2. When the ground state electrons absorb energy which is equal to the energy of difference between the two energy states, that is E2 minus E1, the electrons jumps from ground state E1 to the excited state or higher energy level or the state, that is E2. The electrons in the higher energy level are called excited electrons. The light or the photons energy applied to excite the electrons can be mathematically written as h nu is equal to E2 minus E1, where h is a Planck's constant, nu is a frequency of photon, E1 is a lower energy level of electrons or ground state electrons, E2 is a higher energy level of electrons or excited state electrons. Therefore, absorption occurs only if the energy of photon exactly matches the difference in energy between the two electron shells or the orbits. And this happens when absorption of radiation or the light takes place. Next important parameter in lasing mechanism is spontaneous emission. The process by which excited electrons emit photons while falling to the ground level or lower energy level is called spontaneous emission. Electrons in the atom absorb energy from various sources such as heat, electric field, or light. When the electrons in the ground state or lower energy state, that is E1, absorb sufficient energy from photons, they jump to the excited state or next higher energy state, that is E2, as shown here. The electrons in the excited state do not stay for a long period because the lifetime of electrons in the higher energy state or excited state is very small. It is hardly of the order of 10 raised to minus 8 of seconds. Hence, after a short period, they fall back to the ground state by releasing energy in the form of photons or the light. The energy of released photon is equal to the difference in energy between the two energy states, that is E1 and E2. It means the spontaneous emission happens only when the energy difference is exactly equal to the energy difference between E1 and E2. This is called as a spontaneous emission. Next important parameter in lasing mechanism is stimulated emission. The process by which electrons in excited state are stimulated to emit photons while falling to the ground state or lower energy state is called stimulated emission. Unlike the spontaneous emission, in this process, the light energy or photon energy is supplied to the excited electrons instead of supplying energy to the ground state electrons. The stimulated emission is not a natural process, it is an artificial process. In stimulated emission, the electrons in the excited state need to wait for natural spontaneous emission to occur. An alternative method is used to stimulate excited electrons to emit photons and fall back to ground state. So, the injection of external energy to the electrons which are in the excited state, this process is important in stimulated emission. Next important parameter in lasing action is metastable state. Metastable state, it is a state where excited atom can remain for longer time than normal excited state. Metastable state plays very important role in laser operation to get continuous output of the light. Normally, the metastable state, the lifetime of it is nearly a microsecond to milliseconds. Next important parameter in lasing action is population inversion. So let's see what is this population inversion. The number of atoms per unit volume occupying a certain energy state is called population in that respective energy state. The production of population inversion is a necessary step in the workings of standard laser. To understand the concept of population inversion, consider a very simple assembly of atoms forming a laser medium. Assume there are a group of n atoms, each of which is capable of being in one of two energy states, either the ground state with energy level E1 or the excited state with energy E2, with E2 is greater than E1. The number of these atoms which are in the ground state in given by n1. and the number in the excited state N2. Since there are n atoms in total, therefore capital N is equal to capital N1 plus capital N2. The energy difference between the two states given by delta E12 is equal to E2 minus E1. This determines the characteristic frequency, that is h nu 12 of light, which will interact with the atoms. This is given by the relation, that is characteristic relation, delta E12 is equal to E2 minus E1, that is equal to h nu 12. So as shown in this figure. In higher energy state, that is in excited state, where the energy E2 is greater than E1, the population of atoms is greater as compared to the lower energy state. So that's why N2 is greater than N1 in higher energy state. So this is shown in this diagram. So we can achieve the population inversion with the help of N2 is greater than N1. For the population inversion, if the group of atoms is in thermal equilibrium, it can be shown from Maxwell-Boltzmann statistics that the ratio of the number of atoms in each state is given by the ratio of two Boltzmann distributions. The Boltzmann factor, that is N1 upon N2, is equal to exponential of minus in bracket E2 minus E1 divided by KT, where this N1 is a population in the ground state and N2 is the population of the atoms in excited state, where E2 and E1, these are the energy levels or the energies of excited state and ground state respectively, where K is a Boltzmann constant and T is a temperature. Hence, at thermal equilibrium, there are more number of atoms in lower energy state than the higher energy state, that is N1 is greater than N2. By making number of atoms in higher energy state than the lower energy state by some technique is known as a population inversion. That is N2 is greater than N1, which is I have explained in the previous slide. Next important parameter is active system. A system in which population inversion is achieved is called as a active system. So this is a very basic definition of active system. Next important parameter in lasing action is laser pumping. Laser pumping is the act of energy transfer from an external source into the gain medium of a laser. The energy is absorbed in the medium, producing excited states in its atoms. When the number of particles in one excited state exceeds the number of particles in the ground state or a less excited state, population inversion is achieved. So there are two types of pumpings. Number one is optical pumping. So in optical pumping, photons are used to excite the atoms in the medium using discharge tube. The excited atoms from the uppermost level goes to metastable state to create a state of population inversion. And second one is electrical pumping. So in electrical pumping, the gas is ionized by pulse of high voltage of electricity, by which the gas excites the atoms to uppermost energy level. So in this picture, different discharge tubes used to excite the atoms. Here is helium, neon, argon, krypton and xenon. So these are the 5 examples are given in this picture, that is the discharge tubes. With the help of this, we can get the laser pumping. Next important parameter in lasing action is resonant cavity. And let's see resonant cavity and its types. An optical cavity or resonating cavity or optical resonator is an arrangement of mirrors that forms a standing wave cavity resonator for light waves. Optical cavities are a major component of lasers, which surroundings the gain medium and providing feedback of the laser light. Light confined in the cavity reflects multiple times, producing standing waves for certain resonance frequencies. The standing wave patterns produced are called modes. Longitudinal modes differ only in frequency, while transverse modes differ for different frequencies and have different intensity patterns across the cross-section of the beam. Different resonator types are distinguished by a focal length of the two mirrors and the distance between them. So, as shown in this figure, L is a length, R1 and R2 are the radii of the curvature. So there are certain types of resonators. So first is a plane parallel resonator. So both the faces are parallel to each other. Second one is concentric, that is the spherical one, as shown in this figure. Third one is a confocal. Fourth one is hemispherical, as shown here. And fifth one is concave or the convex. So all these resonators are important to get the unidirectional light of the laser or the minimum diversion of the light. So this is all about the parameters which are important in lasing action. Next point is characteristics of laser. First characteristic is coherence. The light from a laser is said to be coherent, which means that the wavelength of the laser light are in phase and in space and time. Large number of identical photons are emitted through stimulated emission, and therefore they will be in phase with each other. So as shown in this diagram, the incoherent light waves, here you can see the wavelengths are different, whereas coherent light waves shows the same wavelength and they are identical. So we can say that the light is coherent only when the light waves are identical or the wavelength is the same. So this is one of very important characteristic of laser light is a coherence. Next important characteristics of laser light is a monochromatic. Monochromatic light means a light containing a single color or wavelength. The light from a laser typically comes from one atomic transition with a single precise wavelength. So the laser light has a single spectral color and is highly monochromatic light available. In laser, all the emitted photons have the same energy, frequency or wavelength. Hence the light waves or laser have single wavelength or color. Therefore, laser light covers a very narrow range of frequencies or the wavelengths. So in this picture, you can see three types of lasers, three different colors. One is a red, which is absolutely red. Second one is blue, and third one is a green. So because of a very precise wavelength, their colors are very, very accurate. So this is one of very important characteristic of laser, that laser light is monochromatic. Third important characteristic of laser is lasers are highly directional and collimated. Lasers emit light that is highly directional, narrow beam and less divergence. The light from laser emerges in an extremely thin beam with very little divergence. Therefore, the beam is also highly collimated. The high degree of collimation arises from the fact that the cavity of the laser has very nearly parallel front and back mirrors, which constrain the final laser beam to a path which is perpendicular to those mirrors. As a result, laser beams are very narrow and do not spread very much. So in this case, to achieve this, the resonant cavities plays very important role. Angle of divergence, where phi is equal to 1.22 lambda divided by capital D, where capital D is the diameter of laser beam. So this formula is used to find out the divergence angle of the laser. So as shown in this figure, you can see the laser and the laser light is coming here absolute red. So this is the relative beam width. So this is the initial width and this is the final width of the screen. So you can see that highly directional laser beam is there and very narrow cone of divergence can be observed. So from these observations, the lasers are very collimated and highly directional. Next important characteristic of laser is laser is high intensity or with high brightness. In laser, the light spreads in small region of space and in a small wavelength range. Hence, laser light has greater intensity when compared to the ordinary light. So here is a one picture. You can see the laser light is extremely bright or it has high intensity. So this is one of very important characteristic, that laser is very bright or has high intensity. This is all about the characteristics of lasers. That is, lasers are coherent, monochromatic, highly directional and collimated, and has high intensity or extreme brightness. So this is all about the characteristics of lasers. Now let's see the levels of lasers. So first is 3-level laser. In 3-level lasers, consider a group of n atoms with 3 energy states, level 1, 2 and 3 with energies E1, E2 and E3, and populations N1, N2 and N3 respectively. Now let's assume that E1 is less than E2 and E2 is less than E3. That is, the energy of level 2 lies between that of ground state and level 3. So initially the system of atoms is at thermal equilibrium and N1 is nearly equal to N, N2 is nearly equal to N3 and it is nearly equal to 0. The level 3, the energy transition from E1 to E3 as a pump transition as shown in figure. Upon pumping the medium, an appreciable number of atoms will transit to level 3 such that N3 is greater than 0. In level 2, as shown in here in this figure, the energy released in this transition may be emitted as a photon. However, in practice, the transition from 3 to 2 transition, which is shown here, is usually radiationless transition, with the energy being transferred to vibrational motion, that is maybe heat, of the most of material surrounding the atoms, without the generation of a photon. An electron in level 2 may decay by spontaneous emission to the ground state, releasing a photon of frequency nu12, which is given by E2 minus E1 is equal to h nu12, which is shown in this figure. That is the transition. That transition is called as a slow laser transition. A population inversion, that is N2 is greater than N1, has thus been achieved between the levels 1 and 2, and optical amplification of the frequency nu21 can be obtained. So this is the mechanism of 3-level lasers. Next is 4-level laser. In 4 energy levels, energies E1, E2, E3 and E4 and populations N1, N2, N3 and N4 respectively, the energies of each level are such that E1 is less than E2, is less than E3, is less than E4 respectively. The pumping transition excites the atoms in the ground state level 1 into the pump band, that is directly level 4 as shown in this figure. From level 4, the atoms again decay by a fast non-radiative transition into the level 3 as shown here in this diagram. Since the lifetime of the laser transition is long compared to that of the fast transition, a population accumulates in level 3, that is the upper laser level, which may relax by spontaneous or stimulated emission into level 2, that is the lower laser level. This level likewise has a fast non-radiative decay, that is radiationless transition into a ground state. The optical amplification and laser operation can take place between E2 and E3. So this is the laser action actually happens, or the amplification of light happens here. This is about 4-level lasers. This is all about basics of laser and its mechanism, characteristics of lasers, levels of lasers. In next lecture video, I will explain types of lasers, their working mechanism and applications in various fields. So please don't miss my next video. Thank you. Below this video, in the description, the link of important information related to this video is given. Please go through it. Please like and share this video and subscribe to Dr. Khalkar's Classroom channel to get the notifications about my upcoming videos. Thank you.